Céad míle fáilte agus fáilte díobh go léir. Welcome to everyone who has joined us online. I'd especially like to welcome our regular seminar attendees and past speakers who gave so generously of their time and expertise. But today I want to issue a very special Céad míle fáilte to our distinguished guest speaker, one of America's leading research scientists, Dr. Robert Gallo, and also our very own Professor Mary Horgan, who will introduce him. For those of you who don't know me, my name is Rosari Griffin, and I'm the convener of the Centre for Global Development's seminar series. The Centre has been in operation for the past 10 years, bringing academics, researchers, and administrative staff together who are engaged in development work or research. It so happens that I'm also the chair of UCC's Researchers Staff Association, and this association gives support to UCC's researcher staff representing their voices locally, nationally, and internationally. And although it is a voluntary organisation, this association endeavours to represent all UCC researchers, and I would urge any researchers online to join your local higher education RSA. In this final seminar of this semester, I'm delighted that the Centre for Global Development and the Researchers Staff Association are co-hosting this event. The interlinking of the importance of research and of course the critical role of the researcher with the importance of global sustainable development is important. The interweaving of sustainable research with development is arguably best represented through the United Nations Sustainable Development Goals, otherwise best known as the SDGs. These goals help keep us focused in relation to sustainable development for the betterment of humanity as a whole. And of course, we'll hear more about that later on with Dr. Gallo. In chairing today, I'm representing both the Centre and the RSA committees, and I'd like to thank the committee members for their assistance in organising today. A special thanks must go to our director, Dr. Nick Chisholm, who is the Centre Director, and our panellists who are drawn from both committees. I'd also like to thank Dragana Mitovic, our amazing administrator, who has organised the logistics behind today's event. And on the US side, I'd like to thank Dr. Gallo's administrative team, notably Nora Samaranike, Elisa Miller, and Lucia Pearson. Finally, I'd like to thank most sincerely the chairperson of the Global Virus Network, my good friend, attorney Tim Moynihan, and his secretary, Amy Gwynandili, who set the wheels in motion that culminated in Dr. Gallo's presence here today. Apologies in advance if I mention anyone, mea culpa, but all I can say is that today's event is really a team effort. At this stage, I just have to make one or two administrative points for attendees before we proceed. So the main presentation will last approximately 45 minutes, followed by questions and answers. It is a recorded event, and by being here, you have consented to it being recorded. People can feel free to comment or pose questions in the Q&A bar. This will be monitored by our panelists, who I'll come on to later in the Q&A session, and the panelists are drawn from both the CGD and the UCC RSA committees. Feel free, if you wish, to identify yourself when you put your question and your affiliations, and also your comments in the Q&A bar. We will endeavour to get to as many questions as possible afterwards. Also, we have the facility where you can tick questions that you like, so that will push it up the priority list if you feel a question that already exists is an important question. Now for a few brief words about Professor Mary Horgan. Professor Mary Horgan will in fact introduce Dr. Robert Gallo. Professor Mary Horgan is truly a distinguished medic in her own right. She became the first female president of the Royal College of Physicians of Ireland in its 360-year history. She is also a member of NEFIT, which of course a lot of you will be familiar with, is the advisory body to the Irish government on the COVID-19 pandemic and its response. And she is also a former Dean of Medicine here at UCC, and I also had the great pleasure of serving with Mary on UCC's governing body. So all that's left for me is to thank you most sincerely, each and every one of you, for joining us here today. I'll now hand you over to Professor Mary Horgan, who, as aforementioned, has been a leading voice on the COVID-19 pandemic within the Irish context. And we are delighted to have her here today to introduce Dr. Robert Gallo and his magnificent achievements. Over to you, Mary, and thank you.
Thank you very much, Rosari, and thank you and the committee for the pleasure and privilege of introducing Dr. Robert Gallo. For those of us who work in immunology, infectious diseases, virology, he's a household name, and it'll become apparent why that is the case. Dr. Gallo, for the past 25 years, has been director of the Institute of Human Virology and the Homer and Martha Gudalewski Distinguished Professor of Medicine at the University of Maryland. And is also co-founder and scientific advisor of the Global Virus Network. And he reminded me of our Irish connection with that. My colleague, Professor Billy Hall, who ran the VRL up to a few years ago, is involved in that and is a very close friend of Dr. Gallo's. Prior to that, he spent 30 years in the National Cancer Institute in Bethesda, Maryland. And while he was there, he made some pivotal discoveries that really changed our knowledge of medicine and infection. He and his co-workers discovered interleukin-2 in 1976, and it was one of the first cytokines to be discovered and has proven to be a major tool for immunology and the discovery of all human retroviruses. And that leads me on to his, to me, huge contribution to global medicine. He and his colleagues opened and pioneered the field of retrovirology. What retroviruses are, you will all know once you hear them. He was the first to discover the first human retrovirus, HTLV1, which causes an unusual type of leukemia. A year later, he discovered the second known human retrovirus, HVL2. And following on that, and very, very timely, he discovered the third HTLV3, third human retrovirus, which we all know now is HIV. And he was the co-discoverer of HIV. And he was the first to develop really a life-saving blood test. And Dr. Gallo can correct me if I'm wrong, it was either 1983 or 1984. And this was made a huge difference in our ability to manage it. It is about testing and discovery. So he didn't stop there, of course. He went on to discover human herpes virus 6, which is a DNA virus in contrast to the other viruses. And this was the first new herpes virus discovered in 25 years and as a cause of roseola. He also helped co-discover the receptor CCR5, which is really important from HIV biology, and resulted in development of new approaches to treatment of HIV. And why it's so important to remind people, in the 1980s and early 90s, AIDS meant nearly, in the majority of people, death. With the advances that he made, it went from a disease causing death to an infection with which people live really normal lives because of highly effective means of diagnosing it, but also treating it. I suppose on foot of this, he's had, as you can imagine, numerous awards, which include 35 honorary doctorates. He's a member of the US National Academy of Sciences and Institute of Medicine. He's also received other scientific honors and awards, most notably twice receiving the Lasker Award in 1982 and 1986. I'm not going to name all the, because all of the awards would be here for quite some time, but suffice it to say, they're not just North American awards, but they're awards from countries all across the world. Dr. Gallo is the most cited scientist in the world from 1980 and 1990, and he's ranked third in the world for scientific impact for the period 1983 and 2002, with over 1,300 papers published. When I did my fellowship out in Washington University in St. Louis from 90 and then joined faculty out there, Dr. Gallo's achievement from a scientific point of view were known far and wide, particularly to those of us who were training in the field. And I suppose I was privileged to work in a time where disease went, as I said, from one that caused death right to one that we can live with now. And that really is an attribute to the huge input Dr. Gallo and his co-workers had in our understanding of the science. And that's why research is important. It's about critical thinking. It's not about anecdotes. It's about following the science, trying to keep up with the science, trying to keep ahead with the science. So I'm very much looking forward to hearing who really is a role model for those of us who continues to be in research. So over to you, Dr. Gallo.
Thank you very much, Professor Mary Horgan. It's an honor to be introduced by you and a pleasure to see you, I believe, only for the second time, although maybe I'm forgetting one time. And it's a big pleasure to see again Dr. Rosari Griffin. This has been too long. So that was a very kind introduction, and I won't, let's immediately go for it. But again, I'm honored to be introduced by you, Professor Horgan. And those remarks are very kind and very generous and rather thorough. So this is the title, you all have that. So let's get away from it now. I am going to focus in a way on what the topic of the center is, global development, but only from the scientific medical point of view. As you know, I'm limited, and that's what I have to stay with. And I'll try to make it as broad as I can. This is an outline of what I want to talk about. The first, I'd like to discuss some general reflections on pandemics, and keep in mind what it means. Pan means all, and all means that all better be involved. That is, we need absolute global cooperation, collaboration. I'd like to give some lessons from HIV/AIDS, but also the great differences from other pandemics. There is no way to prepare for this one. If we say we're going to prepare for the next pandemic, if it's something like HIV, no, we're not, because it was much too mysterious, and there's nothing you could have really thought about to do. But I'll come back to that, and maybe you'll draw different conclusions. Thirdly, I'd like to talk about key issues regarding SARS, coronavirus 2, and COVID-19. We already said it must involve the world, the complexities of therapy, the great but not lasting and often unavailable vaccines for some people. And what do we do about that? And number 4, I'd like to discuss something you perhaps are not expecting. They don't expect it at my former home at NIH or elsewhere, and that's stimulating innate immunity by use of broadly active old vaccines made for a specific purpose, but not used here for a specific purpose. You're going to say that's strange, but yes, strange but known, and we're knowing it much better right now. I'd like to talk about the roles of government. Rather, I'd like to talk about their limitations. And then I'd like to end with the Global Virus Network, or GVN, and why more should come from private organizations and academic centers, in fact. There have been 6 great pandemics in the past 100 years. It's not that they come every year. That's not true, as some commentators are saying. Well, the next one will be, probably a year after this one or something like that. That's usually not true. It's about every generation and a half, in a sense, with the exception of influenza. You never know when that's going to hit and become broader than just a local phenomenon. So the slide lists 6 of the 6 great pandemics of these past 100 years. But you'll notice that 4 times, the first 3 and number 6, are respiratory viruses, which do indeed cause most pandemics. There's a common feature of all of these, other than being a pandemic, they're all RNA viruses, right? And then I show in red the distinct types of viruses: the flu, influenza, polio, or the retrovirus, HIV, and then the coronavirus. So we have 4 distinct categories of viruses, all RNA viruses, and then a total of 3 that are influenza. Excepting flu, pandemics, as I said already, have been about 1 generation apart, but many epidemics have occurred in between or concurrently. All or most are such as dengue, SARS-1, MERS, other influenza strains, chikungunya, West Nile, Ebola, Zika. They're all caused by RNA viruses. Most are respiratory acute virus infections. They have common characteristics other than what I've said, such as high rates of replication for these guys, as such high mutability, and except for HIV, are very easy to transmit, very easy to find. I don't, account a respiratory virus finding as a discovery. The virus is virtually dripping out of the mouth and nose, easy to find, easy to know it's the cause of the disease. Perhaps the most common feature of any pandemic can be described in one word. Now remember, these are my reflections. You're getting my bias. And as one businessman in France told me, Bob, we all see the rainbow colors from the angle we sit. Keep it in mind. These are my opinions in this case. But, I tried to base it on something. But I think we can say that change is needed for a pandemic. Change in a virus, the genes of the virus, or change in a society, or change in both. For SARS coronavirus 2, we do not know the identity of the change. It likely involves mutations eventually of adequacy to make such an infectious agent of the spike region of the virus. Was there a social change? If there has been, we have to search back for a year or 2 or 3 or 4 or 5 in that region of China to see what that social change was. Was there closer proximity to bat? Was there closer proximity to a mammal that it ran through? These are the unknowns here. Well, consider some past pandemics and epidemics. Can we think of change in most, if not all? Go back to ancient times and to ancient Rome when they went to the Eastern Mediterranean, new epidemics for both areas of the world. When Columbus came to the New World and was followed by European settlers, new epidemics came, pandemics in the Americas, and then some in Europe. It's thought to be syphilis, for example. What about more recent times? What happened with polio? Well, we know polio, or we strongly believe, is a genetic change in the genome of the virus from an enterovirus that was relatively harmless to targeting neuronal cells. This is neurotropism developed. Were there other changes? Did swimming pools have anything to do with it? These are less definitive in this case. Legionnaire's disease, air conditioning, refrigeration. Lyme disease, the deer are in my backyard, literally, because of deforestation. These are, obvious kind of examples. So what about HIV and AIDS? HIV is an infection in the forest from primate, subhuman primate to human. Chimp, some, and gorilla, some. But this has occurred before, probably again and again. The habits didn't change. Habits changed when they moved into the city because of the sudden departure of colonial powers. And what was a rare forest disease became common as increased prostitution occurred and began to spread. We suspect, and there's evidence for, that there was also a genetic change in the virus. So what other change besides a genetic change? The movement, as I said, into the city. But then what happened after World War II? Again, this is my conjecture. After World War II, we had travel, big time travel, increased sexual promiscuity, the insanity of intravenous drug abuse becoming global almost, blood moving from one nation to another. For example, the Japanese were using blood from Europe and from the United States for medical purposes. Hemophiliac, big time change of a blood-borne agent that's difficult otherwise to transmit. So this is a point, change. So those are some common features I'd like to, just to raise with you. I hear commentators say certain things. I don't want to go through who said what, when, and where, but many commentators, including medical people, say we'll never forget. I don't know how many times I heard that on television, on news. So, but we will, be sure that we will. Lessons of all prior virus pandemics show that roughly a generation and a half later, we forget. If we solve SARS tomorrow, I would predict 30 years from now, we forget a lot about this pandemic. I can hear people, including medical commentators, list the great pandemics, and at least a few times. I remember once it was in an audience and they saw that I was there and they changed their remarks and apologized. They never mentioned HIV and AIDS already. And that's not over. The story of HIV, though, is particularly relevant. As I said already, it's often not currently listed as one of the recent pandemics. Strange, strange indeed. Does finding the origin of virus really matter that much? I'm going to challenge, these are, I'll get in trouble with some colleagues for this, but I don't think so. I don't think it's been worth forcing China to eat this and say that the origin is something laboratory wise, we know Dr. Shi, she's a member of the Global Virus Network, terrific scientist. I don't think she did anything wrong. Could it have been an accidental lab leak? Yeah, it could have been an accidental leak from the barbershop also. Somebody got infected. And it's now with new data coming out, it's more than the Wuhan market. There are several markets, not that one market, where they're tracing early infections. I believe this came from bat to mammal to man with no trickery and not somebody in the lab going out and infecting people. However, you can't really disprove the latter, can we? That can be said about any virus epidemic or pandemic. With polio, I said genetic change, but there's also suggestions that it might have happened also concentrated in an American Army barrack in World War I in Kansas. We don't prove it, but that's a thought. I don't think there's good evidence to suggest anything from a Chinese lab, but be that as it may, I am going to be publishing with Dr. Dean Jameson of UCSF, a small article in one of America's magazines, a visible one. And we're going to say origin of SARS coronavirus 2, doesn't really matter. And I tell you, I don't think so much. Why? Because we already know what to do if it's born in a market, or if it has a mammalian intermediate, or if it's a bat directly to man. We know what to do if it was a lab leak. I won't have time to go into this, but the things are obvious that we should go forward and do. And then you'll say, well, what about gain of function research? Well, gain of function research can be important. If I were my colleague friend, Dr. Fauci, Tony, I would have acknowledged, yeah, so we do fund gain of function research sometimes because it was sometimes essential. Sometimes we need to know, and we try to be as careful as possible. But we know what to do if there was. I think we would just, the Asilomar conferences in California, we're going to suggest that. They were for molecular biology, for gene cloning, where scientists met and decided they would have lay people involved in reviewing also. Intelligent lay people or intelligent scientists from fields outside virology, because we're too tempted. A virologist is not frequently going to say no to something, particularly funding and exciting research. So we need something for the public to see more visibly. But in the end, I repeat, I don't think it's worth chasing and pushing China on this. We'll only succeed in pushing them away from collaboration. So as you can see, I'm free to say what I think. I don't have any politics or political gains. And at my age, honestly, you don't fear anything. There's nothing to worry about, right? So lessons from HIV. So part 2 of this talk. This is a very different kind of virus. Well, I can tell you in the 1960s, before you look at the slide, if you can listen to me for a second on this, I came to the National Cancer Institute of NIH in the mid-1960s, and there, at a time, there was a healthy respect for serious infectious disease, epidemics, pandemics, et cetera, and a feeling that we had to help other people. I don't know what happened, but by the middle of the 1970s, this notion disappeared. Departments of microbiology were under threat. Some of them were actually eliminated. I don't want to say where. And there was a feeling that this was a problem for tropical disease institutes. It's a problem for those people, not for us people, which you wouldn't say today because it's politically incorrect. It's also untrue. So serious epidemic diseases were supposed to be over in the industrialized world. Therefore, forget about them. There was a strong feeling that retroviruses don't infect humans. And there were many reasons for this. I can just simply tell you that going to a Cold Spring Harbor meeting at one time, and I always worked independent things, not just controversial things like human retroviruses. But I remember a well-known scientist saying loudly when I entered the room, oh, here comes Bob with his RNA rumor viruses. They used to be called RNA tumor viruses, retroviruses. Those things stung. The first paper we published on the discovery of the first human retrovirus, HTLV1, was absolutely rejected and with insults. Thank God for the proceedings of the US National Academy of Sciences. It then published and the walls began to break. The third was that no virus causes cancer in man or plays any role in any stage of any cancer. This was a conclusion of 1974 book published and meeting that I attended of the Cold Spring Harbor Laboratories on the Conference on Origins of Human Cancer. So these were the biases of the 70s. But the biases were destroyed by the early 80s, and viruses were shown to be the cause or involved in a stage of the origin of at least 20% of human cancers. Retroviruses were found in humans, shown to cause a particular leukemia, not some leukemias, that's wrong. And the same virus, you know, we used to say one gene, one protein. Now it's one gene. You could have more than one protein functioning. You could modify that gene post-translationally. We used to say one agent, one disease. Well, that's certainly untrue. In this virus, HTLV1 causes not only a leukemia, but a paralytic spastic neurological disease and modest immune abnormalities. One of the great pandemics of history appeared, caused by another retrovirus, as you already heard by Professor Horgan. How did the developments occur? I'm going to take you through some of those moments, but in summary form. Howard Temin and David Baltimore discovered reverse transcriptase. Howard Temin predicted that retroviruses could go from RNA to DNA. This is before they were called retrovirus. This is reversal of the central dogma of molecular biology. RNA to DNA, how strange, how criticized Temin was. As I was in the 70s, he was in the 60s. Temin was the most brilliant and the most high integrity scientist I ever knew. And I was so happy and proud to have him as a friend. He was actually who I tried to, well, stay close to as much as I could. So our approach was to develop methods to grow primary human blood cells using growth factors that had just been discovered by Rita Levi-Montalcini in Rome, nerve growth factor, and Stanley Cohen in Vanderbilt, epidermal growth factor. So we got into it very early when there weren't any more growth factor, there were not any more growth factors known. We coupled this need to grow human blood cells just for the sake that I was interested in human leukemia, so I wanted to study their biology, their biochemistry, but I also wanted to look at whether I could find retroviruses from these cells, and you had to grow them. And we coupled this with finding ultra-sensitive but specific assays for finding a retrovirus. Reverse transcriptase that Temin and Baltimore had discovered is a DNA-making enzyme, a DNA polymerase. We have several in our cells. I was working on them by chance. Reverse transcriptase provided three major advances for all biology. They provided a mechanism for Temin's provirus theory. They became a powerful tool that impacted molecular biology in several ways. For example, a big part of gene cloning. But for us, reverse transcriptase might become a surrogate marker for a retrovirus. It did. It's 1,000 times more sensitive than electron microscopy. It allows for frequent sampling of cultures for testing for a new virus. This is important. If a virus is released periodically in bursts, you can't do electron microscopy every 15 minutes. Frankly speaking, I've never even seen an electron microscope. Finding them in a burst is ideal for something like a reverse transcriptase assay of an aliquot of your culture. Ultimately, we repeatedly isolated a novel retrovirus from human CD4 positive leukemic T cells called HTLV1, much different than other pandemic or epidemic other viruses, much more difficult to find. Many other infections. Now I'm switching to HIV, and I'm sorry I didn't put that on the slide. A long period from infection to disease, very different from pandemic, what we're used to. This is a picture of the first human retrovirus, HTLV1. Leukemic blast cells below, the virus budding from a cell membrane, which used to be required before you publish, no longer is this true because of molecular biology. This is the first human being from which retrovirus was isolated, an American 28 years old from the southern part of the United States. No interesting history, occupational, sexual, personal, social, anything. The lesions that you see are leukemic cells infiltrating his skin. Very, very aggressive disease in about 85% of cases. Usually death within a year. He passed away very quickly following this. It has a very definite kind of pattern, a pattern distinct enough that Takatsuki in Japan described it as a unique leukemia, and that helped us make breakthroughs for really pinning down etiology of this disease and finding it in America and in Britain and among Caribbean people and Western African tribes and in the Aboriginal population and in Japan and in Iran and in Romania. Strange places and all over South America, but particularly Peru, Brazil, Colombia, where it's really a problem. Discovery of HTLV1 and 2 directly led to the discovery of HIV. This is not known, but I need to tell you about it. Where do ideas come from? And where did the technology come from? HIV didn't just drop like manna from heaven into our lap for finding it. Rather, the idea came because AIDS features described by the clinicians who made the first observation, and then the epidemiologists who made the second scientific observation, were similar to what we knew about HTLVs. AIDS, well, CD4 T cells declined. That was described in 1981. The mode of transmission by epidemiologists like James Curran, now at Emory, when he was at CDC, blood, sex, mother to infant. This is what we knew about HTLV1. The CD4 T cell tropism was also what we knew about HTLV1. The long latency to disease, obvious from the history of the patient and following them, the immune impairment, and a prevalence in Haiti, where HTLV1 was endemic, is endemic. These seem to fit, and we figured this was going to be in the HTLV family and a new human retrovirus. We were right, it's a new human retrovirus. This led to productivity of all the theories. I won't have time to go through the various theories. If this was a talk solely about HIV, I would do that. But it was the most productive, but in the end, we also thought it was going to be in the HTLV family. Lo and behold, of all things, humans have a second class of human retroviruses, which seem to be converging in their evolution towards the HTLVs or the HTLVs towards HIV. Not clear. They have a lot of common properties, and even in some of their genomic structure, yet they are a different kind of subgroup. Technically, the methods for growth and culture of human T cells based on interleukin-2 cytokine enabled us to find HIV in any other lab as well. The method for sensitive and specific tests for retroviruses based on reverse transcriptase work in the 70s in allowing frequent culture sampling. It's not moving. Oh, sorry. Finding the virus was one thing, but showing it was the cause was another. Think how different this is for SARS coronavirus 2 or for most acute virus infections. For all acute virus infections, AIDS was different. It presented unique challenges, unlike the past epidemics of the recent coronavirus. The latency. I mean, you don't ask a patient what they did a decade ago, neither does a public health person. The multiplicity of microbial infections that a person had by the time they had AIDS, it's the only time you could recognize the problem. Which one was causative? Turns out, none. None that were evident were causative. How are you going to prepare for this? I had several great clinical collaborators listed at the bottom. They didn't just provide samples, they provided conversational discussions as well. We finally published in four papers in Science and one in Lancet in the early spring of 1984. Professor Horgan asked me when would the blood test come, and you'll see exactly how it happened. We were detecting the virus throughout 83. When we published, we had 48. We published not on one isolate. It's sometimes kind of forgotten, but we published 48 different isolates from 48 different patients in our first report. And by January of 1985, PNAS, 105 isolates, as well as some additional isolates coming from the Paris group. But I still thought this was nonetheless sufficient for us to conclude and publish that this was the cause of AIDS, because verification or confirmation in my mind is necessary for science to progress. Verification by virus isolation would be extremely difficult because tissue specimens were limited and not even allowed in some institutions from fear. The T cell culture technology was not widely available in virology labs. They didn't have interleukin-2 or knowledge about it. AIDS had to be clinically recognized, and by that time, the patient generally had very few T cells in their blood to culture, making virus isolation very tricky. For example, let's say we had 20 patients samples coming to us. Maybe we sample 3, 5, 10, 15, 18, 20 would be positive and the others would be negative. We were going crazy trying to figure out. By positive, I mean finding reverse transcriptase, clearly reverse transcriptase, not a cellular artifact of a cellular DNA polymerase. Finding it in a particulate fraction, in the soup, in the extracellular fluid, or at the membrane. Clearly a presence of a retrovirus. We weren't able to really characterize yet, so we were hesitant what would happen if we published. We were afraid. So we continued until a development occurred. In the fall of 1983 was a key advance. If you go to the bottom, you'll see who did it. With me was Mika Popovic from the Czech Republic, and Betsy Reed-Knoll, my technician now at NIH, and Ursel Richardson, who died young, my technician also. What we developed was the capacity to continually grow in cell culture, permanent cell lines of several, 6 to be exact, of our isolates of HIV. Not all we know today will grow in a permanent cell line, only some. But it made several things possible. Most importantly for me was the blood test, but also enabled drug screening, detailed molecular analysis of HIV genes and proteins and so on. So there was rapid movement at this point in time, to the point where Jonathan Mann, the late Jonathan Mann of WHO, said it was the fastest pace in medical history from a mysterious new disease. The blood test was able to verify the cause because it was safe, simple, sensitive, accurate, inexpensive, and rapid. So verification came globally almost instantly, enabling surveys of thousands and thousands of sera all over the world and removing any doubt that we should let these papers fly. The blood test was a key advance for helping with saving the blood supply, especially for hemophiliacs and the plasma at the time, and allowed the epidemic to be followed for the first time before you had to wait for a person to have AIDS. So we could follow the epidemic, epidemiologists could, I really mean. The culture system allowed the first screening for anti-HIV drugs. And when therapy became available, we could determine who to treat, as well as blocking mother-to-child transmission. And for us, it also verified HIV as the cause of AIDS. An accurate, sensitive diagnostics are key to any pandemic or epidemic. Coming out of that last slide, I just wanted to go over to this for a second. The reasons are obvious, but they're still underappreciated. It's critical to have accurate diagnostics and sensitive diagnostics. We did poorly, rather, in the early days of the current SARS coronavirus pandemic. Why? I list 5 reasons. No responsible group or groups. It lacked leadership. Cross reactions with harmless seasonal coronavirus relatives. Insufficient global cooperation, and likely also fear of the virus. I take 1 and 4 as particularly troubling. It was said to be that CDC was responsible, but we developed a blood test for HIV when I was at NIH, not CDC. I consider this a failure, not of any group, not of NIH, not of CDC, but of all of us, the medical scientific community, because it's not any one particular person's responsibility or group. No one ever planted a statement across CDC and say, you're the responsible for all global epidemics and pandemics for diagnostics. So what did our institute do? Nothing. And what did I do? Nothing. We assumed that this was so easy that the rapid, a lot of virus on the tongue and the mouth, it's going to be simple to get the virus. It was. It should be easy with modern technology to have the best possible diagnostic. So I believe. I honestly, I give you the reasons that I think there, but truly, I'm not sure. There's more to the story than I know, I think. But it took so long to get good diagnostics. About therapy for HIV and AIDS, and back to HIV. Before the beginning of AIDS, it was thought to be more or less impossible to target systemic viral diseases because of the precision needed in therapy. As you know, viruses lack metabolism. It's not like a bacteria that can be hit with an antibiotic outside the cell. But advances of molecular biology in the 1970s regarding the steps of replication of viruses in general opened the door for precision therapy. Their genomes of viruses do encode some proteins, although they use us. They use their intracellular parasites and they use us for their replication. They use a lot of our machinery. Nonetheless, they do encode some proteins that are necessary for their replication. And they synthesize with cell help their structural proteins and usually have other genes making proteins that inhibit some immune attack. They really try too hard to avoid innate immunity. They're very susceptible to innate immunity if it's there in advance. And by innate immunity, I mainly mean for us interferon and natural killer cells. Bad late in disease after infection for inflammation, essential at the beginning. Thus, understanding at least some aspects of the HIV replication cycle was critical. As molecular biology advances, it made steps in replication understandable. The beginning and the breakthrough. It is not 1995 with the cocktail. The cocktail was straightforward and obvious. Once drugs are available, of course, you're going to combine them and test them. But it was early 1985. Our cell line culture was available for testing drugs. Burroughs Wellcome called us on the phone and wanted to test some things they had. So it was Burroughs Wellcome company, David Barry, who really pushed it. Sam Broder was a young doctor at the National Cancer Institute, eventually became director of the National Cancer Institute, and he came to my lab. And he tested their compounds that we got when we went down there. I lectured, he got the compounds. And we found that AZT inhibited reverse transcriptase greater than the human cellular DNA polymerases in vitro cell-free tests. But then he applied it to the cultures of the HIV-infected cells, and he found that it inhibited them without much toxicity. Then Broder and his colleague, Robert Yarshorn, by the way, he did that earlier work with a Japanese postdoctoral named Mitsui. Broder and Bob Yarshorn at NCI to this day, with Burroughs Wellcome, showed its efficacy in a New England Journal of Medicine paper, with CD4 increasing while HIV decreased. In my view, this is a massively underrated and historical achievement. It is the first time an antiviral drug showed clinical efficacy in a systemic virus disease, and it brought the pharmaceutical companies far more into the field with courage and confidence. Now it is taken for granted we should treat viral diseases. Anti-HIV and AIDS therapy, present and future. Well, I want to make a big jump from where we were to where we are now. The focus now is cure. What do we mean by cure? People should define it as so-called functional cure. I don't even know why the word cure is mentioned. What one is after is no need for therapy anymore and leading a normal and completely full and longevity, like a right longevity of one's life. And it's likely doable. The approach is, I don't like this one, the shock and kill. It's the one that's been in vogue for the past 10 years. And I don't think it's ever going to work. Why? Because the shock doesn't reach all sites. It's usually insufficient. The subject is subject to toxicity from activating other genes of the cell, as well as activating other viruses, as well as the potential toxicity of the compounds themselves. The idea for the kill of the virus expressing cells was from the cytotoxic effects of expressed virus, but we know from the earliest HIV research days, not all cells that express virus die. Then the idea emerged that the kill will come from cytotoxic T cells, but there are limited numbers of these cells, and the HIV variants are going to defeat it in my mind. This is my view. If this approach did work, anti-HIV drugs would then be used to prevent any released virus from infecting new cells. I think it's an overfunded and overstressed area. This will not get me votes for election for mayor, but it's what I think. Anti-HIV and AIDS therapy of the future. I like this. Block and lock, they call it. This means the opposite sort of shock and kill. You seek to continue a strong, long-lasting HIV latency so that there's no viral genes expressed. It may be easier to do. Maybe that's enough to do. But then there are others who say, let's do more. Let's follow it with attempts at removal of the sequence by the CRISPR-Cas9 story. Cut it out specifically. This has a future, I think, and is somewhat exciting. For my own limitations and my own interest, I would like to better understand the pathogenesis of HIV. As for SARS-CoV-2, interferon alpha is a positive factor in acute infection with HIV, but detrimental in the hyperactivated chronic phase, killing normal CD4 T cells. We reported this over 30 years ago. Therapy of AIDS with interferon alpha predictably gave dangerously bad results. We have recently shown, but not yet published, that a key to the elite controllers of HIV that live with the virus and do very well, at least for 10 years before any change occurs and they become like other HIV infected people. And we have a great correlation, and it's somehow they control the overproduction of interferon alpha. This is new. You're not going to get a lot out of this because it's not even published yet, but I can't help myself from sharing it with you. So we are thinking of targeting interferon alpha in the chronic phase and augmenting what's called interferon lambda, because interferon lambda doesn't knock off CD4 positive normal adaptive immune response cells like alpha does. because CD4 T cells lack lambda receptors, but yet it's also potently antiviral and it doesn't have so much of the inflammatory response. I don't want to go through the rest of that. It gets too complicated. We need to determine how they control, these elite controllers, HIV without therapy for many years. And I just emphasize what we think is part of the story, if not a very big part of the story. But is it genetic? Is there something special about them? Or is it simply that they were exposed to a lower dose of virus at the beginning, avoiding the early permanent immune structural fibrotic damage? But even if this were so, and I do think there's a genetic component, but even if it were not true, if it was just a low virus titer, finding precisely what mechanism they use to functionally distinguish them may be rewarding for therapy and even for a preventive vaccine. Moving to a preventive vaccine, it can't be entirely based on the principles from classic virus vaccinology because as a retrovirus, it puts its genes in our cells within 1 day. It leaves little time for immune recall. It has to be there all the time. Its error-prone DNA polymerase helps rapidly produce variants. The consequences are we likely need sterilizing immunity, no virus getting in. And a protective immune response need to last, which is not required by prior vaccines. The status for a vaccine for HIV is, however, depressing. A continued failure of numerous trials, including 2 recent NIH-sponsored trials from National Institute of Allergy and Infectious Disease. Most of them based on broadly neutralizing antibodies, BN, ABS listed there, or on delivery with adenovirus vectors, which in my mind activates too many CD4 T cells, houses for HIV to replicate. Well, both of these were huge failures, and they're not really published yet. There is the policy of funding a lot on neutralizing antibodies. I believe we're lacking investigators, young, with investigator-initiated different ideas. We're going to have to go more in that direction. The problem with antibodies are the titers needed are never reached. The great variation of HIV outrun the antibodies. The antibodies do not last long. The integration of the just like with SARS coronavirus 2, and you could predict it by the nature of the spike or envelope protein. The glycosylation pattern, the sugar patterns on the envelope allows us to predict. Indeed, in January of 2020, we predicted that the SARS coronavirus vaccine, if and when it comes, would not last more than 6 months, and that's panning out. Integration of the HI genome in a day requires immunity to be ever present. Upon vaccination, many T cells are activated, and those cells are the sites of HIV replication. We could be forced to use drugs, long-lasting, non-toxic, inexpensive for HIV prevention, and it may be doable, something if time permits we could discuss. The great positives in summary of HIV/AIDS were the rapid understanding of the cause of a very complex disease and rapid development of a very accurate blood test. This was also a complex, mysterious disease. Historical therapy against a systemic viral disease. We don't often hear it mentioned. I read in your leaflet, Rosari, that about how generic drugs may save the day for the developing world. But in Africa, I think we hesitate to remember the PEPFAR program, the President's Emergency Program for AIDS Relief. Streets in Africa are named for George W. Bush. We know the history of the Iraq War. We know the mistakes, but we cannot, and historically it won't be forgotten, that he created the PEPFAR program, $58 billion for Africa. And it's been increased by all American presidents, surprisingly in one case, continually. So it still goes on. This has been a great help for African drug development. Our institute is in 8 different countries in Africa due to the PEPFAR program funded through CDC. Then there's the great disappointments of HIV/AIDS. Of course, the vaccine, the failure to overcome the epidemic of drugs, certainly in our country. And despite PEPFAR, and despite other national and international organizations, we have much more to solve in Africa, along with some other places. Some specifics of SARS-2 and COVID-19 with one slide. We already said a bunch of this, but number 2, it must involve the world. It's essential for China, US, Europe, close collaboration. scientifically wise. Knowing the origin is not critical as claimed, in my view. That's an opinion. Diagnostics, not very solid in the early stages. We discussed that. The complexity of therapy. Don't have time to go into it, but it's complex. The vaccines are great, but not long lasting. The variants are likely to be covered, I believe. I'm not so worried about that, but limited availability for the world. And as long as there is the world involved, we will have this coming back, even if we're just selfish. And lastly, a role for stimulation of innate immunity. This is now something I want to talk about. Stimulating innate immunity with broadly active, old, well-known, safe vaccines, such as measles, mumps, rubella, MMR, oral polio vaccine, live shingles, live intranasal flu, yellow fever, the bacterium BCG, also Corynebacterium parvum, another bacterium, rotaviruses, and more. There's lots of inferential data from different parts of the world for years, but with COVID now, it's starting to become quite impressive. What do we mean by innate immunity versus adaptive immunity? Okay, well, I'm not going to, you know, the adaptive immune response with antibodies and specific CTLs, killer T cells, and you know, the antibodies are specific. Durability can be very long, like measles or polio or mumps and rubella or smallpox or papillomaviruses, or even hepatitis virus, hepatitis B. But it's present only in vertebrates. But we, all creatures, have innate immunity. So we, as mammals, have, of course, adaptive immunity, but we also have innate. And the efficacy of adaptive is, of course, virus specific, but the efficacy in innate is broad. And interestingly, it's effective almost immediately. I had it last night and I got better. How many times in your life did you feel not so well, but you were better the next day or 2 days? That's your innate immune system, certainly not your adaptive. And it's the majority of times that you are cured of something is your innate immune system. So it's effective broadly against many viruses. For example, you activate with foreign RNA your toll-like receptors. They have receptors known as pathogen-associated molecular receptors, or PAMPs. The problem with innate immune stimulation is it's short-lived, but it can be months. If you were a tourist, a soldier, and you were heading, let's say, into Egypt, and you were told that a new epidemic was of a respiratory disease in particular was moving quickly through where you were going. If it were me, I'd like to have in my pocket something like measles, mumps, rubella, or oral polio vaccine, or something like that, because I know that I've got a good chance of being totally protected fast within 1 hour. Non-specifically, but effectively. It's inexpensive. Oral polio is 10 cents, 12 cents. It could be available for developing world. It could have been available to me and you in January 2020 when we proposed it, but didn't get funded. No one gets particularly funded for this, and this is an argument that is not popular, and there's more than one reason for that. So the arguments for the importance of the innate immunity with SARS-CoV-2, bats harbor coronaviruses, bats in general. They hold it in check solely by innate immune mechanisms. These mammals live the longest of any mammal with a rapid metabolic rate. They lived into their 40s, and yet they have one of the highest metabolic rates known because they fly. And they're protected by this constant low-level activation of interferon and NK cells. Substantial genetic information is being used by SARS-CoV-2 in its relatively small genome. Substantial amount is used to specifically attempt to avoid innate immunity. Clinically, a better prognosis correlates mainly with innate immunity parameters. Durability is the advantage of conventional, adaptive, immune-stimulating vaccines, the specific ones. But the classical vaccine approach with SARS-CoV-2 does not yield antibodies that are durable. Clinical evidence that higher levels of interferon correlate with better prognosis. I think I've said that already. Yeah, I twice did it. Now there are several correlative positive clinical studies that exist. So opportunities for using innate immune stimulating vaccines. At the beginning of any new epidemic or pandemic, to fill in the gap of time between appearance of a new epidemic and developing an effective, durable, specific vaccine, which is usually over 2 years and sometimes never. For countries that cannot gain access to the specific vaccine for even longer. Third, if there's a problem with durability of the specific vaccine, or if that vaccine is unable to handle some variants, we don't see this yet, or maybe never occur, with the specific vaccines for SARS, coronavirus 2. Maybe we could couple these live attenuated old vaccines with specific vaccines, because it should, with more innate immunity, make adaptive immunity work better. That's what specific vaccines do. You have to start with innate immunity induction. When you get the messenger RNA from Moderna or Pfizer or anybody else, any vaccine for SARS, you first stimulate innate immunity, but poorly so with those kind of vaccines. What if we use these with it? If people say, well, maybe it'll interfere. No, it won't interfere. It'll help it for almost certainly. Okay. What are some of the problems going forward with innate stimulating older vaccines? A lack of understanding among populations and even scientists. A fear that there may be confusion in the public and lead to greater vaccination resistance. The low durability, probably only a few months. The unjustified fear of side effects. And the concerns they may interfere with specific vaccines. No market value, very inexpensive. The role of government. Well, which government? Many differed one from another. I don't want to go through it all, but think Japan, which wouldn't want to do anything. Think Sweden, which wanted herd immunity. Think Trump. I think, I don't know, Boris Johnson. Which one do you listen to? We need the government for funding. We need it for oversight and ultimate decisions. But they're limited in the knowledge base and expertise in science. Yes, you have some, but why would you limit it when we can have the best in the world? There's a cry for globally connected private organizations with adequate funding. The Global Virus Network was established in 2011, but it didn't get off the ground until about 2014, 2015. Why? Trading, overcoming the lack of number of quality virologists for every single kind of pathogenic virus there is. That's what we aimed for and did. And, you know, you would be surprised that people were finding, even in HIV, that we were having a decline in real virologists. Also for advocacy and advisory of public health people, helping solve virus science problems with expertise for every virus type as funding becomes available, and bridging of nations. Our president that I recruited 5 years ago is Christian Brichot. He used to be the president of Pasteur Institute in Paris. He was also the president of INSERM, the funding agency for France. He was also the head of the Mérieux Institute in Lyon. And he is now president of the Global Virus Network for close to 5 years now. It was founded, well, I already said that. It's a global organization, is in Baltimore. The founders are shown in the newspaper article on the right. To the left of the page is Reinhard Kurth, unfortunately died. Was the director of the Koch Institute, and Billy Hall on my other side from Dublin. It's nonprofit, and it's a coalition based of leading virologists, and you know what those purposes are for. That's our institute, by the way, on the right side, part of the Baltimore Center and the University of Maryland campus. I was recruited there by the governor when I was leaving NIH. The network, that's where we have centers of excellence, that not just it's the bright colors, but also the faded colors where the ball is over them. So there's 66 centers of excellence now, 10 affiliated institutions for 76 in 35 countries. Programs, research, we don't have time to get into this because I only have a couple of minutes left. But the most important are these task forces and banks. Like we had a Zika serum bank, which was greatly helpful to people in different parts of the world for Zika when it was breaking out. We have task force for chikungunya. We have a task force for HTLV1 that helped a lot in Australia. Again, not time to go into unless somebody was asking. And now we have a very huge SARS coronavirus 2 task force. And we have biobank. Training and education, we have a short course in Baltimore. We get people from developing nations. We have an academy that they belong to, an alumni group that they belong to. They keep in contact, and we're building up about usually about 20 people per year. So we're about 100 right now. We haven't had any in the last 2.5 years because of the pandemic. So we provide postdoctoral fellows, at least 2 to 3 a year, provided by relationships with pharmaceutical industry. They are allowed to go anywhere to 2 different centers of excellence for training. And then they get a certificate when done after that period of time. The short course, they get some certificate from, and then there's an online course also. Advocacy, we won't have time to go into it, but if you glance at the right side, you can see where advocacy has been, particularly with press releases, op-eds, newsletters, and perspectives, and seminar series. The task force lists here. There are 32 GVN centers in 13 countries involved in SARS coronavirus task force. We meet bi-weekly, virtually. We share the most recent and advanced research findings. I can tell you we were learning about what was going on in China before our government was aware. We were talking to them and learning about what was going to happen and the genome be coming out, et cetera. We've had 24 meetings on coronavirus 2 so far with the task force, which is listed there. I'm sorry you can't really read them, but believe me, they are experts from different parts of the world. We have the biobank, which I mentioned already. For example, serum storage, clinical sample storage, analyzing data storage and making it available, establishment of that database system by analytical and clinical data for evaluating therapeutic and diagnostic protocols. We have public education, which I've already hinted at and won't go into it. Briscoe also has a health and care blog, the GVN weekly brief, the SARS coronavirus 2 published perspectives that are done by my former molecular virologist, Marvin Rice, with help from others, including my son. GVN, this is the coming very end now. This is the second to last meeting we had. This is Lake Annecy in France, not far, I guess, from Lyon, though I wasn't sure exactly where I was. The meeting after that was in Barcelona. We haven't had any meeting internationally in the last few years, but you can see we've been in Washington, Naples, Munich, Beijing, Japan, Australia, France, Spain, and we were heading for other places, but I forgot Munich and Moscow in 2013 as well. Okay. The regional meetings are held in various places. That's Sharon Lewin on the right lower part. She's in Australia. She holds the regional meeting for that part of the world. With Lim-Fa Wang is probably, in my mind, is the greatest coronavirus virologist in the world, and he's in Singapore. He's a regional center director. So we have regional meetings and we have regional center directors now. Last week, 10 days ago, we had a meeting in Monaco on diagnostics, which I didn't attend. I was supposed to, but I heard it was really quite terrific, with the best futuristic diagnostics for viruses you could imagine, with companies and with private organizations, but mainly academia. We mentioned about the short course. We have this at the University of Maryland at the Institute of Human Virology, but we also work at NIH, at Hopkins. We also take them usually to the White House to tour the White House. They have some dinners together. They get to be friends and they come from different parts of the world. And they spend that period in the summertime at our Institute of Human Virology. Webinar series, which I hinted to before, and the Academy program. Well, this is just everything we have that's scholastically related. Christian Briscoe wanted to establish this at the GVN Academy, and he did. The postdoctoral fellowship I told you about. So these people can pick any center they want to. They can spend 1 year in one or 2 years, but then go to a second one if they want for the second year. 3 trainees were supported by the pharmaceutical industry last year. They want to get something out of it. They usually have some particular interest, and it's mutually beneficial. We have what's called a Rising Star program. We select a few faculty, young, who look like they're going to be stars, and we highlight them as much as possible, and we give them benefits and opportunities and some funding for future possibilities of further training so that they become real virology scholars and leaders. It's going to become, this is the end, a worldwide information resource for vaccines and the variants. And they have the corporate partnerships with the number of companies is not updated now, but they have interest in diagnostics and having it tested and biosafety things of their products that we can work out arrangements with. but they pay for it and we cannot sign off on it that other than give them data. A discovery network for emerging pathogens. Postdoctoral fellows sometimes will go back to the company if they want jobs at the company of reasonably good paying jobs, etc. Advocacy, this tells our press releases, our op-eds, articles, 116 radio appearances, 30 TV appearances, and so on. That's Christian in the middle, and at the bottom middle with staff. So thank you very much for this invitation, for your attention, for your time. My wife is Mary Jane Hayes, and she and I are hoping to return to Ireland this year. We really do miss it, and we miss some of you. Thanks.
Thank you very much, Dr. Gallo. That was a wonderful presentation, very comprehensive. And because I don't come from a medical background, I'm going to pass immediately to Professor Mary Horgan to put the first question to you. Thank you.
Thanks, Rosari. What a fantastic talk, Bob. The first question I'm going to ask, and was something we continue to observe here, is the kind of lack of global coordination when it comes to this current pandemic. And I can say we live in the EU, and I'm not too sure how cohesive we have been in our response other than vaccine rollout. But when the South Africans shared their data on Omicron 4 weeks ago now, all of a sudden they were penalized because everything was shut down very quickly, all travel and so on. And so really discouraging people to, you know, I suppose, to own up and do the right thing. Your thoughts on that? And the second question then is the kind of rush, the panic, when we don't have all the science about virulence when it comes to Omicron, and you can appreciate the impact restrictions have on our young people, our children, education, our economy. Do we rush into things a little bit too much on knee-jerk reaction? So they're my two questions.
Okay, well, one of my favorite answers lately has been that my colleagues and I, in the past, and my colleagues, I try to remember this, we don't use enough free words. I don't know. And for sure, I don't know the answers to your things, but I will make my speculation if I can. You know, I'm moved by he's a good friend, Salim Karim, who provided a lot of that data in South Africa at Cape Town at Caprisa. So he's been we gave him our Lifetime Achievement Award, actually, not so long ago, he and his wife, Carisha. So he's a very wise fellow. And I tend to listen to what he says. And he provided a lot of that data to us, and he gave a terrific webinar in our task force on this whole story as it was coming out. And I'm impressed by the arguments that were really hurting them badly by cutting off the travel. I travel, some people don't. So I can only speak for myself, but it's hard for me to tell somebody to travel or not to travel, because I don't know, you know, how dangerous it was in South Africa. Well, we all know this much, that nothing stays permanent with this virus, right? I mean, Chinese came to study the fashion industry in Milan, and one of the great epidemics in Europe happened very early on, right, a streak right across North Italy, you know, following almost the Po Valley and the industrial towns and around Milan. And Chinese had gone home and then come back for the Moon Festival or something, and their public health system was kind of wiped out. Now, would I have recommended traveling to Milan at that time? Would you have? No, I don't think we would. But in the course of time with the pandemic, this thing was not overrunning everything in South Africa, but to believe that we wouldn't take it home was a little bit absurd, right? I mean, we know we're going to have it. And by the time they were talking about it, we were having it already, and it was already spread. In fact, we don't really know where it came from, only that it spread faster in South Africa, right? We don't have the original patients. So I would think it's certainly time to stop it, to allow, not to bias South Africa. Whatever policy is going to be, let it be, but don't make it on one group. That's the best I could say. Because Africa is one of the last places we can afford to hurt. So I'd be more liberal, but I don't want to tell you I know I'm right.
Okay, we've quite a lot of questions in the chat bar. Professor Mary, did you want to respond to that, or will I keep going?
Yeah, I just think, 18 months later, we really need to optimize the tools that we have to, live with it meaningfully. And I know it's always challenging with Christmas coming and all the intergenerational mixing, but I do think that's really important.
Mary, pardon me, Professor Horgan,
Fine.
Yeah, that shouldn't. This is awkward for me to say because it's difficult for people maybe to get their hands on, and also people don't know it, and some of my colleagues don't know it. But I know what I'm sure of what I'm saying. If I go to South Africa, if I go anywhere, you can be sure that I go to my drugstore, CVS, with $10 and I buy measles, mumps, rubella, I can't get OPV. I'll be protected. I'm confident of that. So if I'm going to, would I accept South Africa? Yeah, but I go to my drugstore and I get MMR, and 1 hour later, I'm going to have high innate immunity, and I'm going to last for a month or 2 or 3. And, that's it. And so you can say, well, is there real proof of that? Yeah, there is. It's a hard one to talk about because I had a slide that gave more reasons why it's difficult to, people are afraid that they'll get confused with the specific vaccines. You can barely get some people to take the specific ones. Now, what are they talking about? They want me to take something like measles, mumps, rubella. This is crazy. I don't have the courage to face it, frankly speaking. And some of my colleagues don't want me to bring it up, but I know what I'm talking about. And I can tell you, our friend Billy will be injecting himself shortly again. And Anders Wallny, his friend from the Karolinska Institute in Sweden, will be taking it. And I can tell you the bulk of the GVN center directors will be taking it. So we honestly know what we're doing, but we're afraid to speak it out. But yes, I would go to South Africa, and this is what I would do. And that's all I can say. But I don't want to go further. I'll get hell from somebody.
Thank you, Dr. Gallo, and thank you, Professor Mary Horgan, for kicking off the discussion. I would invite all the panelists to put on their screens, if you don't mind. And we have 8 questions in the chat bar, Dr. Gallo, so we will try to get to all of them. So in order to facilitate everybody who's participated and who has a question. So we'll turn now to another Centre for Global Development Committee member, which is Dr. Barbara Doyle Prestwich, and Barbara is the head of climate science in the School of Biological, Earth and Environmental Science, or School of Bees as it's known as. Barbara, there's a question from the chat bar.
Oh yeah, just very quickly, Dr. Gallo, first of all, thank you for a really nice presentation. As you know, this seminar has been co-hosted by the Centre for Global Development, and I suppose I just wanted your thoughts on how important you think centres of global development are in university settings to address some of the, the issues that you brought up there.
Well, first of all, how important it is, the magnitude of it is, I don't know, but how can you argue against it? I mean, you can't argue against it, right? In the world we live in today, which is an interconnected world, and certainly an interconnected microbial world and disease world. And for development of some of the countries on Earth, let's just take the medical side of it, not the agricultural or the plant, but just the medical side of it. Wouldn't it be important to have somebody constantly knocking on your door that says, global development, not just you? It's not just Europe and America. It's not just Europe, America, Australia, Japan, etc. We better be sure we're thinking about Indonesia, Africa, etc. So I would say, yeah, it would be interesting to have it around our neighborhood. Our institute is a separate, not a silo because we do interact, but we're a separate building here. But across the street are other things, Shock Trauma Center, the Genome Center. Would be nice to have somebody thinking of the world, not just our local backyard. So how could I ever argue against that? It's certainly a good. And no one could argue against it.
Yeah.
That's what I could say. But the magnitude of it, well, that's going to depend on its the receptiveness it gets, I guess, and it's going to depend on the determination of the ability of the people in it.
And we need all of that. Okay, thank you, Dr. Gallo. Rosari, I'll pass back.
Thank you. Thanks very much, Barbara. That's great. Our next panelist is Dr. Cathal O'Mahony. He's a EU funding manager in the SFI, which is Science Foundation Ireland Marai Centre as part of UCC, and also a member of the UCC Researchers Staff Association. What question from the bar have you got, Cathal? Thank you.
Thanks, Rosari, and thanks very much, Dr. Gallo. We have a question here from Dr. Gordon Dalton, who is chair of the International Consortium of Research Staff Associations. He starts off actually by also thanking you, Dr. Gallo, for a very inspiring presentation. Question has got a couple of strands, so I'll just take them, put them all together if that's okay. So basically, as someone who's led an international research team over many decades, did you feel at any point this work was compromised perhaps by the short-term nature of research staff that you had within your team or employed? Was it difficult to maintain a world-class team? And as most of your research team is based in the US, has the career of the researcher in the US become more short-term over time, say in the last decade or two? Thank you very much.
Thank you for the question. Good questions. I had no trouble at the National Cancer Institute of NIH. This is all subject to somewhat to chance, but at NIH, you have money and you have a budget, and I never had a problem because one or two directors I had good relations with, and they believed in me. And even though I was controversial as heck, particularly with human retroviruses, I was really problematic. And I was the first person they ever had a site visit for in the history of NIH. And boy, they had a tough group. But strangely enough, it went well. And, you know, if I ran out of money, I just asked and I got it. So our research group was really strong when I was there. In fact, Mandy Fisher was one postdoc who left. She was good. I didn't think much more about her for a little while. A few years later, she was in the Royal Society for doing studies in embryology. Turns out to be quite brilliant. And Mandy is doing something that they're putting up in, well, I'm going to forget. It's something by the Thames River. It's something important. And they get a picture of our lab, part of our lab anyway. It's only about half. And then it was in a magazine. And we made some jokes, and they're putting it there for that period of time. So I had people stay for a few years, at least the postdoctoral fellows, and several stayed on forever, then became jobs in America. I would say probably about a fourth of the people would come. In those days, people came from Europe. These days, it's much less, at least where I am now involved. Declined in some of the countries more than others. We certainly don't have the same percentage from Europe as we used to. Now you get Middle East. I mean, I have 2 people from Iran. You know, America's strange, right? I mean, they're totally acceptable. And so we have Persians. We have Middle Eastern people. We have South American people. We have Central American people now. Some Russians come. Chinese are overwhelming numbers in America, in case you don't know that. They're in every department, in every place you go to. No matter how remote it is, you'll find Chinese scientists in medical science. Now less when there was this troubles in the last 2 years. But the decline is nothing compared to the mass that are there. But what's coming in tremendous numbers now are from India. There's a few from Pakistan, which I found out are not our allies, but lots from India today. So, and those people, a lot will stay, including Chinese, but the Indians, great numbers, and some Europeans do stay too.
Okay.
So,
sorry.
Yeah, I mean, so the answer is complex. That they, you know, and they're not so short with me. Today, it's shorter than it used to be, and in America, it's less. less than it was. These are not the golden years. They are not the years of coal or dust, but they're not the golden years. The golden years, the 60s, when I came, the late 50s, the 60s, the 70s, to the mid 80s, late 80s. It's not golden years at NIH anymore, or in American biomedical science as much as it was. But I think Europe is much, much better than it used to be. I mean, honestly, and it's just to close with this, I used to feel, I tell you the truth, I used to feel sorry for people in Europe. I honestly felt sorry for them. I mean, everybody, I mean, Germany too. Less so with Britain, less so. I mean, I don't remember feeling sorry for Britain, but the continental, I really used to feel sorry for all. I said, you know, they just, I don't know. I didn't know what was the trouble. I thought they had enough funds. I didn't know, but it's much better today. So
Thank you.
Thank you very much, Dr. Gallo. That's an area we'd like to explore more, but I'm going to continue around. And our next panelist is another executive committee member of the Centre for Global Development, Dr. Claire Doherty, and she is the lecturer in Applied Social Studies and is the academic director of the Diploma in Development and Global Human Rights Studies. So Claire, what question have you alighted upon?
Thanks, Rosari, and thanks to Dr. Gallo for a really, really interesting presentation. Some of it is a social science I could follow, other parts I couldn't. But I suppose my question...
I'm sorry. That's my fault.
No.
Always the fault of the speaker. That it means that I went into some things I shouldn't have gone into, and I have to know what that is.
No, not at all. Not at all. There's things I've learned from it also.
I shouldn't. So you understand.
The question, I suppose, follows on a little bit from Professor Mary Horgan's question. And my question was, and it also feeds in with a question in the chat. And you spoke about the need for better collaboration and even the need to draw on the expertise of developing countries. And could you say a little bit more about how you think that might happen when it seems that there is very little political buy-in? So I was just wondering, do you think that the Global Virus Network has a role in that regard? And the question that was in the chat, which relates to that, is from Antonio Hyder, and who asked the question, we have been carefully listening to your perspective for the last 2 years and are so thankful to you. However, during this time, governments seem to go in their own directions. What can populations do in this mess? So I guess it's asking about the contradictions between scientific collaboration and political collaboration.
I'm not expert on the political collaboration. I would probably more gum it up and rely on somebody that's better than me for this kind of thing. I'm too used to not knowing how to smooth things out when I want to say something. So, of course, we think the Global Virus Network has a role to do this. How do we build relations with other countries when we don't have good relations? People often draw on sports and entertainment, but don't you think biomedical science could be more drastically important and more effective in bringing people together? And the sharing of people. I mean, China shared a lot of people with us, still do, but that's not exactly working. But I think if we can't do it with medical cooperation, I don't think it can be done. So my answer would be, we hold up the GVN and say, catch it if you can. Try to become a member. I can tell you who's really comes in strong, wants it so badly, is Russia. You know, China takes it slower, but Russia's really interested in being involved. And I don't mean Russian politically, but Russian institutions very strongly want to be involved, making trips over, telling how good they are. And, you know, this, they can do that, they can do this and that. And slowly they're coming in. So now we're just there's been one in very strongly. And there's now 2 more last week, actually. My son is on this committee and he keeps me posted on it, and they really don't we think that Russian institutions being involved would at least help a bit to have political understanding and involvement? They see what we're doing, they hear what we're doing, they want to do more of this, that, and the other, right? So I mean, I'm collaborating with Iran. We have Persians in our institute, but out of the blue, I get a letter from a guy named Professor Habib Zada. Well, he's head of he's medical head of all the petroleum industry. He is really smart. And so I was really impressed. And he wanted to work on innate immunity, right? He did 2 marvelous studies. One's in Press and PLOS One, one's in Press and JAMA, JAMA. 2 really reasonably visible journals on the efficacy of OPV for coronavirus, SARS-CoV-2. I'm a co-author with him. I can tell you, I was awkward being an author because I said, look, I've done nothing. And he said, no, you got to be the one sponsoring this and go forward with it. And he is a brilliant fellow, a Persian, Iran. You know, supposedly our real problem, right? Our problem guy. I couldn't be closer to this guy. Isn't that the beginning of something? That's GVN. So we have a multiplicity of GVN people with it. He asked to be involved in GVN. And, you know, we went through this and it turns out we said, we're going to make a grave mistake being GVN Iran. We're going to get in problems in our own country. I said, Jesus, he's going to be then GVN, a major member and an advisor totally to the GVN in public health. I hope, what else can I do? I'm not good in the politics. I am not my friend at NIH, Tony, who's very, very good at that. I'm not. And so, but I think this way we can make the contacts and help. So do I believe that GVN can be helpful? I think it can be a major tool, Now, you know, you have Ireland involved, make it even more involved, get even closer. Your health officials, talk to Billy, say, look, we need to be playing a role in this. This is not some ego thing or anything else. Yeah, to be the center of excellence, you have to know something about at least 1 virus or 2. But you don't have to be that to be a member, to be an associate, to be an advisor to the board, to be on the board, as Rosari knows, because she's been nominated to our board by Mr. Moynihan and is now just coming up in discussion. She's turning red. I can just see the Irish in her right now. She's shy. Look at that. Like, oh boy, it's like when I was in high school. All the Irish. Oh boy.
Oh,
anyway, you know.
Thank you very much, Dr. Gallo.
Play a greater role in the GVN and decide for yourself. I think.
Thank you.
Okay.
Thank you, Dr. Gallo. I'm not sure how to follow on with that. I'll just turn to our last panelist, if that's okay. And that's Colette Cunningham. And Colette is a lecturer in global public health at the School of Public Health. And she is passionate about health equity. So, and she's also a member of the Centre for Global Development. So Colette, please. Thank you.
Thanks very much, Rosari. And thank you, Dr. Gallo, as well. And I have 2 questions. One is from one of our questions on the chat, the questions and answers, and that's from Dr. Brian Turner, who's in the School of Economics. And so I'm going to start with that one, and then I have one of my own as well. So Brian's question is, why do you think, he thanks you also for a really interesting presentation, and why do you think SARS-CoV-2 has spread so widely where previous viruses, example, previous SARS viruses and Mars avian flu did not?
It's entirely related, as far as I can tell, to the receptor and to the spike and to the receptor and the enormous affinity that it has. There may be more to the story. Some people think so. They think there might even be a second receptor, as there is with HIV. But there's certainly, number one, the cell receptor, the ACE2, is widespread. It's not like on HIV, which is limited to CD4 positive T cells that also have the co-receptors CCR5 or CXCR4. So these are 2 very specific receptors and limits the cell targets, right? This guy has receptors that are on cells all over the body. All right, so this makes it a nice, comfortable place. And the affinity is really high between this spike and that particular receptor, making infection. Look, respiratory infections are pretty easy anyway, but this is more aerosol and able to spread more widely in a room. It looks like to me, and that's one thing. But I mean, you're going to get infected with influenza. My cousin's wife she's not young, but she's very ill right now with influenza. They diagnosed influenza type A. She can die just as easily. Influenza is very infectious too. I mean, if you're going into restaurants and it's the flu season, you've got a good chance of getting infected. I mean, you get over it usually, and then you don't think too much about it, but it doesn't seem to be able to get through the room so much with aerosol. And this guy does. So I think that's two things: the spread by aerosol. Some people have said asymptomatic people don't transmit, but the Chinese showed that it did with this very readily, and asymptomatic viral diseases do transmit in the asymptomatic phase, and this one does it very effectively. And I think the aerosol is part, the virus titer is part. It replicates a lot in the individual, so you're getting pretty healthy doses, and the receptors all over the place in your body, and the affinity of the spike for the receptor is really fantastic. So those are things that make it spread much more.
Okay, thank you very much for that. And my own question is in relation to the relationship between HIV and COVID, particularly on the African continent. You mentioned PEPFAR earlier, and I was involved in PEPFAR in the early days for quite a number of years in Africa. And I'm just wondering, with so much, there's a success story in Africa with treatment and care of HIV, and there's very proficient centres have been set up all across the continent, but those centres don't seem to be used efficiently at the moment in relation to COVID. And is it possible for to garner support from, say, the Global Fund, from the PEPFAR Fund, and now COVAX as well, and to marry all of those together, as it were, to get COVID more advanced, the vaccination, etc., more advanced on the continent?
You raise a very good question. And you're absolutely right that although we try to take care of the whole person with I can only speak about our programs, which there are 8 different countries, and it's very big, it's very heavy. It's equivalent to some of the big universities in the United States, and we're just a simple institute, but we have a lot of funding and we're in a lot of places. In fact, we did the first and only study of an entire country of HIV positivity or negativity. The country of Nigeria was done by a Dr. Man Charirat, the head of our epidemiology and prevention program for all Nigeria. Although you can take care of the whole patient, but using funds for the other virus is thought to be no. In fact, NIH is getting in a little bit of trouble right now for doing exactly that, shifting funds from HIV into SARS coronavirus 2 and COVID. And they're now going to get some political problems for it, because that money is supposed to be sacrosanct, No, should it be? You raise a very good question. That would need to be a discussion, and I think you'll get an outcry from some people that'll say, no, you can't touch that money. So I'm not optimistic that can take place, at least not by American funds, maybe European, maybe somebody else who may be willing to give some money without catches. I think a little more pressure might be put on China. They're not poor, obviously. And they do have things in developing nations, but usually there's some military payback, the bases or something along those lines. But I think the world could put a little more pressure that they do a little more contribution. But anyway, you do raise a good point, but I don't think the answer is going to be positive.
Okay.
Thank you very much.
Right.
Thank you, Colette, and thank you very much, Dr. Gallo. I'm afraid that's all we have time for in relation to questions and answers, but there are still a lot of interesting questions in the Q&A. So what we will try and do is get them answered. We might send them on to you, Dr. Gallo, and perhaps put a question to you. Mary, did you have anything to add before I pass over to Dr. Nick Chisholm, who will give the final closing remarks?
I suppose on behalf of the world, really just to thank you for all the work you've done in virology, and really in my lifetime, seeing a disease that from which you die, well, certainly in the developed world, to one that we live with now was phenomenal. And a lot of that is attributable to the work in your scientific curiosity. So big thanks on behalf of UCC and the larger global infection community.
Thank you. Thank you very much, Professor Horgan. I have really one question for you. Do you know Dr. Mary Klotman? Professor Mary Klotman.
Where is she based?
She's the dean now at Duke University. She used to be my postdoc, and she looks very much like you. So, yeah, if you see her, if she puts glasses on, you're going to think it's maybe you. Yeah, Mary was an excellent postdoctoral with me it's a long time ago, so I won't say that for but it's back when I was at NIH, and she was very young. Yeah, okay. Anyway, I couldn't help but say that because I look and I say, Jesus, Mary Klotman. Okay. Thank you.
Thank you, Dr. Gallo. And again, thanks to all our participants. And before we close, I just want to again say we will try and get to all of your questions. We'll maybe put them to Dr. Gallo and
I'll answer them. Yes, sure. I'll answer them. I mean, particularly, I'm going to have another knee replacement, so I can tell you I'll be sitting around.
Great.
I'll need some company. Your questions will be useful.
Thank you so much. Yeah, we'll get back to you on
Thank
that.
you.
No. Before you leave, I just want to pass you over to Dr. Nick Chisholm, who is the director of the Centre for Global Development and a senior lecturer in international development in UCC, to make our closing remarks. And on behalf of myself, Rosari, and all of the team here, thank you so much. And over to you, Nick. Thank you.
Thanks, Rosari. And thanks, Dr. Gallo. It was really a fantastic and enlightening and stimulating presentation. And we really feel honored that you've given your time to make the presentation to us today. And I must say, I'm amazed at your continued energy and enthusiasm. It's very inspiring, I must say. So I suppose.
What's the choice?
Well, that's true. That's true. So anyway, I suppose COVID-19 has kind of reminded us of the scale of the huge global societal challenges that we face, and obviously the work that you've done, both in regard to COVID-19, but more particularly with regard to HIV/AIDS, is just absolutely phenomenal. And I suppose it shows the importance of the combination of really top quality science, the need for good policy, and the need for global solidarity. And I think that's come up in a number of the questions, I think, and obviously it's the reason why we have a Centre for Global Development, is to kind of focus on that global perspective. And it was very, I like the way you said, what's the value of Centres for Global Development? Well, it reminds us of the need for global development, not just us. And I think that's to some extent what we're all about, So we can see with regard to COVID-19 that there's still a lot more to do in terms of ensuring access and affordability for developing countries in particular, and that's obviously a big issue. And I'm very interested then in I mean, I'm not a medical person, but I'm very interested in the your discussion around innate immunity and the potential for that. I'd like to learn more about that, and I can see us all going off for our MMR jabs actually to kind of get around some of these current.
Yes.
Anyway, yeah, I think, but I think I was working in Ethiopia in the mid-1990s when HIV was absolutely, and that time there wasn't much government recognition of the extent of the problem. But I think it's fair to say, so there was a resistance within developing country governments as well, but I think it's fair to say that, that sort of combination of science, policy, and global solidarity in the end led to a very substantial response to HIV/AIDS. And as Professor Horgan said, that it's, and because of, your work and others, that it's actually turned HIV/AIDS into a disease that people were dying from, to a disease that people can live with. So that, I mean, it's a huge testament to you, but also, as I say, to the way in which global responses can be effectively developed. So I suppose just to say very, very briefly about the center at the CGD here, I mean, this is what we're doing really. We're trying to raise awareness of these great sort of global societal challenges, and both within UCC and more widely in the community in Ireland. And we do that through seminars such as this, through university-wide modules, through interdisciplinary research and similar activities. And I think I suppose it's kind of an encouragement to us in the kind of work we're doing to hear such great presentation that it makes us, you know, sort of, I suppose it sort of validates the work that we're trying to do and the importance of it. So I suppose all I can say in closing is that we're delighted to have had such an eminent speaker to sort of close off the series for this year. And you know, we really sort of appreciate you giving your time. So just to say thanks again to you, Dr. Gallo, to Professor Mary Hogan, who I know is extremely busy with a range of activities, not least addressing the COVID-19 issues here. A big thanks to Rosari for having organized the seminar, and also thanks to the panelists, Claire, Colette, Barbara, and Cathal, and also in the background, Dragana, for doing a fantastic job in technical support. And I hope I mentioned everybody, and apologies to anybody I've left out. But with that, I think we'll close. And I think just to say in closing, to wish everybody a safe, peaceful, and enjoyable Christmas and New Year. With that, I think we'll close.
Thank you. Merry Christmas to all of you.
Thank you.
Merry Christmas.
Merry Christmas.
Same to you, Dr. Gallo. Thank you so much.
I hope to see you wandering the West Coast someday.
Oh, yeah.
Absolutely.
All
You're very
take
welcome.
care. Bye-bye now.
Thanks a
Bye,
lot.
everyone.
Thank you.
Thank you.
Bye. Thanks,
Thank
everyone.
you. Bye-bye.
Bye.
You gone, Rosari?
Yes, she is. Yes, she is.
Okay. Thanks, Dragana. Thank
Thank
you.
you.
Bye-bye.
Bye.